Kia ora koutou. This is the second video for people working from home today, March 17th, 2022. So in the first video, I got through the questions from 5.5 and 5.6, but I didn't manage to do these two really nice ones from 5.7. What we're looking at here is how we can use compound angle identities to help us when we're given a little bit of information about another trig thing. So what we're going to do is work with exact values, so you can put your calculators away and get your brains ready to go. We're going to be working, when we've got questions like these, in the first quadrant. And the benefit of working in the first quadrant is we know that all of the trig ratios in here are going to be positive. And it means that we can always set things up when we're given first quadrant things as a little right angle triangle in here. We're going to use Pythagoras' theorem extensively, and we're never going to find the angle in here. We're just going to be finding different trig ratios. So this first question is kind of a classic example. We're given cos of x is 7 over 25, and we're given sine of y is 12 over 13. And we have to find sine of x minus y without using a calculator. So if we just go to a new page and draw out what we've got cosine of x is 7 over 25. So let's draw a dinky little triangle and put on a 7 and put on a 25. So that's just using year 10 trig, so katoa. The angle is going to be this one here. So this is x is the angle, and we can figure out what this is. And you can probably see where this is going already. This is a Pythagorean triple that you might know or you might not. So we know the 3, 4, 5 triangle, and we know the 5, 12, 13 triangle. This one is probably the third best known, and you can figure it out for yourself. 25 squared minus 7 squared leaves us with 576, which is 24 squared. So we've got a side length here, which is 24. And once we know that, that means we can find all of the trig ratios for that triangle. We were asked to find here sine of x minus y. So we've done the x triangle. Let's do the y triangle. Just shrink that a wee bit. So here's my next triangle. Sine of y is equal to 12 over 13. So this is 13. This is my right angle. This side is 12. Opposite over hypotenuse, and this side will be 5. Using my compound angle identities, we know that sine of x minus y is sine x cos y minus cos x sine y. And we can substitute those values really easily now. Sine of x will equal 24 over 25, and cos of y will equal 5 over 13, right? So that's using the new third side of each of those triangles. So here we've got 24 over 25 times cos of y, 5/13, minus 7/25 for cos of x, which we were given, times sine of y, 12/13, which we were given. So working that through, my common denominator already done for me is 325. 5 24s are 120. 7 12s are 84. So my final answer here is 36 over 325. I think the answers have got that as a decimal. I'd leave that as a fraction or a decimal. It's fine either way. But I said not to use your calculator, so I guess leave it as a fraction. And then the next question is very similar, but it's using cotangents. So actually this one's even easier. It's going to use the tan compound angle. So here, cot of D is equal to 2/5, and cot of E is equal to 3/5. Now, I didn't even draw triangles for this one. We could do, but we don't have to. We're asked to find the cotangent of E minus D. Well, we know that the cotangent of an angle is 1 over the tangent. So tan of E minus D. And now we're going to use our compound angle for tan. Right, so I'm going to write this out just for people who are still getting their heads around it. Tan of E minus D is going to equal tan E minus tan D over 1 plus tan E tan D. So 1 over that is going to be here. It's going to be 1 plus tan E tan D over tan E minus tan D. Right, so it's just this and then flipped upside down. So we're taking the reciprocal. And we know cot of D is 2 over 5. So tan D is the reciprocal. It's 5 over 2. And tan E is 5 over 3. So putting all of that together and erasing that mess from the last video, we've got 1 plus 5 over 2 times 5 over 3 divided by 5/3 minus 5 over 2, which looks like the kind of thing I'd give my Year 9s for some fractions revision. Maybe I'll do that next week. Equals 1 plus 25 over 6 divided by 10 minus 15 over 6, which equals 31 over 6 divided by negative 5 over 6, which is negative 31 over 5, skipping a tiny step in there. So there you go. Those kind of problems come up. They come up in Cambridge a wee bit. This big idea also comes up in scholarship calculus quite often. And so if you can see a way that you can work in a third side of a right angle triangle, that's usually going to help you in solving problems like this. Okay, that's all from me for today. That should get you right through 5.5, 5.6, 5.7, and then 5.8 and 9 are actually, they should be good to do as well. So just email me if you've got any trouble with any of that. Thanks for watching.